Here's the goal for today. I know if I can solve different types of ratio problems. Okay, so today you get to the point to see what you know and what you don't know, to be self-aware of what you know and what you have to still study. Okay, so let's go through some of these problems together. What is the ratio of pentagons to circles? Okay, so I'm going to count up the pentagons, and I'm going to count up the circles, and I can use the word 2 in between, I can use a colon, I could even make a fraction. So there's 2 pentagons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 circles. Okay, so what is the ratio of circles to pentagons? Okay, it's a different picture, so you have to count them up again, but you're going to do the circles first. 1, 2, 3, 4, 15 circles I'm getting. And 1, 2, 3, 4 pentagons. Okay, so circles to pentagons. Okay, so this one's asking you to go backwards. Draw a picture where the ratio of squares to triangles is 8 to 9. Okay, so I would need 8 squares and 1, 2, 3, 4, 5, 6, 7, 8, 9 triangles. Okay, it doesn't matter what order you put them in when you're drawing them, but 8 squares to 9 triangles. Okay, the ratio of cars to trucks in a parking lot is 1 to 4. Write a sentence starting with "for every" to demonstrate the meaning of this ratio. Okay, so your sentence is going to start off with "for every," and you're going to explain what these numbers mean. Okay, so you have to say what the 1 goes to, and the 1 goes back to the cars, because the cars is mentioned first. Okay, so for every 1 car, there are, and the 4 goes back to the trucks, so for every 1 car, there are 4 trucks. Okay, that's what the meaning of the ratio 1 to 4 is in this problem. For every 4 swings at the park, there were 2 slides. What is the ratio of slides to swings? Okay, so still asking you to write a ratio, but they ask you to write the slides first. Okay, so there are 2 slides to 4 swings. Now we can reduce that to 1 to 2, okay, but I'm going to leave it 2 to 4. The ratio of problems finished to problems left to do on a quiz is 4 to 1. What is the ratio of problems finished? Okay, problems finished, they tell me, to total problems. Okay, so if there were 4 problems finished and 1 problem left to do, there would be 5 total problems. So that second number should be 5. 4 problems finished out of the 5 total problems. Okay, number 7. You have to fill in the table below to show how many hot dogs were sold if 30 fries were sold. Okay, so hot dogs to fries was 2 to 5. Okay, what if I have 4 hot dogs? Then I would have sold 10 fries. Okay, so every time I go up by 2 for hot dogs, I have to go up by 5 for fries. And I have to keep going until I get up to 30 fries. Okay, so for fries, 5, 10, 15, 20, 25, 30. 2, 4, 6, 8, 10, 12. Okay, so they're asking for how many hot dogs were sold? 12 hot dogs. Okay, just make sure you're always going back to read the question. See if it's asking for a ratio, if it's asking for one of them, or if it's asking for the combined amount. Okay, for a baseball team, the ratio of games won to games lost was 9 to 1. Okay, so games won to games lost was 9 to 1. Create a table below to show how many games the team lost if they won 36. Okay, so for the winning row, I have to keep going up by 9 until I get to 36. And for the losing row, I'm going to go up by 1s. And then I'll go back and look at the question. Question says, what is the total number of games played? Okay, so I'm going to have to add up 36 games that they won plus 4 games that they lost. They played 40 games in total. Okay, number 9. For every 2 laps that you jog, you walk 3 laps. Use equivalent ratios. Okay, so this is a different method. Okay, we're not going to do a table. So every 2 laps that you jog, you walk 3 laps. So we're comparing jogging to walking. Two laps jogged and 3 laps walked. Okay, so instead of writing a table, okay, usually we would set it up like this. Well, it's almost the same idea, except we're not going to have a table, we're going to have a fraction. How many laps you jog if you walk 24 laps? Okay, so I'm walking 24, so I'm going to make this equal to another fraction. Equivalent means equal. And that 24 I'm going to put on the bottom, because that's where we put walking. Okay, so we're deciding, well, what do I have to multiply this fraction by to turn it into a 24? 3 times what is 24? That should be 3 times 8. Multiply the numerator by the same number, 2 times 8, and I get 16. Okay, so you have to jog 16 laps. Okay, one more with equivalent ratios. For every 6 handfuls of popcorn that you ate, you drank 2 sips of soda. Okay, so we're talking about handfuls of popcorn and sips of soda. But instead of doing a table, I'm going to do equivalent ratios or equivalent fractions. So 6 handfuls of popcorn for 2 sips of soda. And let me read for that last number they give me. Use equivalent ratios to show the sips of soda you drank if you ate 48 handfuls of popcorn. Okay, so the popcorn, that 48 is going to be my numerator. That's where we put popcorn, in the numerator. So we're figuring out, how do we turn that 6 into a 48? Well, 6 times 8 is 48. So do the same to the denominator. And 2 times 8 is 16. Okay, so you had 16 sips of soda. Okay, another topic that we reviewed was equivalent fractions or simplifying fractions. Okay, so for these numbers, 12 and 16, we're going to find the greatest common factor, and then we'll use it to reduce. Okay, so the greatest common factor is the biggest number that could go into both of these numbers. Now, if you're not sure of it, you can write all of the factors for 12 and 16. Okay, so 1 times 12. That's one way to get 12. 2 times 6, that's another way to get 12. And 3 times 4 is the last way. So those are all the factors of 12. For 16, 1 times 16. 2 times 8. 3 doesn't work, but 4 times itself is also 16. So the biggest number they have in common is a 4. Okay, so that's what we're going to divide by. Divide the numerator and denominator by 4. Okay, so our greatest common factor is 4. And when I reduce that, 12 divided by 4 is 3. And in the denominator, 16 divided by 4 is 4. So my reduced fraction, or my simplest form, is 3 over 4. Okay, find the greatest common factor, and then use that to reduce. Okay, so greatest common factor, the biggest number that goes into 30 and 45 is 15. If you're not sure, you're going to make that table to find your GCF. So I'm going to divide those both by 15. 30 divided by 15 is 2. 45 divided by 15 is 3. Okay, one more. Reduce 28 over 32. Okay, let's check our factors. So I'm not sure of this one. 2 times 14. 3 doesn't work. 4 times 7. And to get 32, 1 times 32. 2 times 16. 3 doesn't work. 4 times 8. And 5 and 6 do not work. So it looks like 4 is my GCF. So divide those by 4. I get 7 over 8. All right, and the last topic to review. Oh, sorry, this is still equivalent. Write two ratios that are equivalent to 2 over 7. Okay, so 2 over 7, it's already reduced. I can't reduce that fraction anymore. So let's make these numbers bigger. Let's multiply them by 2 over 2, maybe. That would give me 4 over 14. So that's one equivalent ratio. You can multiply by 3 over 3. Okay, you can multiply by anything as long as the number on top and bottom that you're multiplying is the same. Okay, 3 divided by 3, this is really multiplying by 1. 2 times 3 is 6. 7 times 3 is 21. Okay, so there are a lot of answers here. You could have multiplied by 4 over 4 or 5 over 5. Okay. All right, now here's the last topic. Changing a fraction to a decimal. Okay, so 3 divided by 8. You're going to do long division, and that number that's on top goes inside the long division symbol. Okay, so 3 divided by 8. 8 does not go into 3. Okay, so I'm going to have a decimal. If I add a 0, 8 goes into 30 3 times, because 3 times 8 is 24. 30 minus 24 is 6. I need another 0. Now 8 goes into 67 times, because 7 times 8 is 56. Need another 0. And 8 goes into 45 times, because 5 times 8 is 40. I'm done because there is no remainder. So 0.375. 9 divided by 100. Remember, the 9 goes inside that long division symbol. 9 divided by 100. 100 does not go into 9. I'm going to put a 0 on top of the 9. Bring up my decimal. 100 still does not go into 90, so where that 90 ends, I need a 0. 100 goes into 900 9 times, because 9 times 100 is 900. So 0.09. Okay, and our last one, 2 divided by 6. Okay, so 2 is going inside this long division sign. Add a decimal and a 0, because 6 does not go into 2. 6 goes into 20 3 times, 3 times 6 is 18. 20 minus 18 is 2. I need another 0. 6 goes into 20 3 times. Okay, we already did 6 into 20. 3 times 6 is 18. Okay, so you should start seeing a pattern here. I keep getting this 20 that I have to divide into. 6 goes into 20 3 times. Alright, so this is going to keep going on and on forever. That 3 is repeating. Okay, so we put a bar on top to show that it's going to be 3s forever and ever. 0.3 repeating.